Okay, let's talk agent observability and start with how we're doing observability today. Metrics, tracing, logging, we have this in cloud native apps today. So let's examine first how that looks, and then we'll compare it to how that might change and differ and present new challenges and requirements in a world of agentic architectures. So like for a classic cloud native app, let's say we have a backend for front end here that's fronting 3 APIs on the back end. So in this scenario, and if we look at tracing specifically, I might use tracing with a goal of debugging a flow, okay? And what I really want to do is if there's exceptional activity in a given feature or functionality in this app, in this backend for front end, I actually want to walk the entire tree of like what the data flow was and the request flow was from that front end service to whatever other backend APIs, and maybe even beyond to a database beyond that. Now, this, even in mature environments, this can be a difficult challenge from an instrumentation perspective to make sure that all of these components are actually originating and propagating traces. But we can kind of work around that with technologies like a service mesh, that if the application or service isn't implemented to actually support propagation of traces or participate in a span, we can make sure that at least we're creating traces individually for each network hop. And this is still somewhat useful because for these classic applications, I have code that goes along with the actual trace material. So I can basically look at the code, given an input, I can look at the code and the trace and walk the path of what's happening. And that's why it's really useful from a debugging standpoint. But let's compare that to how agents work. So from an agentic architecture standpoint, let's say a user is giving a prompt to an agent, all right? That agent, the brain of every agent is an LLM. So that agent is going to talk to an LLM. That agent is also going to talk to one or more tools to interact with its environment, understand its environment, maybe even mutate its environment through a tool server via MCP. And it may actually talk to other agents as well. Now, an interesting detail here is this gets recursive because that agent here can then, of course, call other agents, which can invoke other tools and LLMs and this type of thing, right? Now, the end-to-end goal here is actually to have explainability and auditability. The reason for this is that agents, because they rely on LLMs, are inherently non-deterministic. In this picture, there is no code base that shows me with a given input what path I will take every time. The value of agents and being based on LLMs is that they're non-deterministic, that they're somewhat random. That's what makes them very useful, right? But that also is responsible for things that we don't want, like hallucinations, or could be responsible for potential attack vectors where there's a tool injection or a prompt injection where I need to actually track that down. So ultimately, at the end of the day, when this agent gets a prompt from a user, even the same prompt multiple times in a row, I might need to go through a trace end to end and understand exactly what happened so I can account for any adverse outcomes, whether it was I exfiltrated some data or it was just a suboptimal outcome to the user's goal. And keep in mind, on this side, we actually have a well-defined schema-based API contract, right? Here we have natural language. So even for the input, forget about the behavior of the agent, even the input is completely wide open. And again, this underscores the need for end-to-end observability and traceability in this architecture. So let's take those 3 key primitives there of origination, propagation, and context. And by the way, in both of these architectures, this isn't a completely new observability architecture. For both cloud native and agent native architectures, we're going to use OpenTelemetry as a base. Okay, out of the box, OpenTelemetry is well tuned for classic cloud native applications, but needs to be enhanced to handle the type of observability and tracing that we're seeing on the agentic architecture side. Now, why origination is important in all architectures, we need to start the trace somewhere, right? And the more important thing is we only want one trace, okay? So I can pick up any agent framework I want, most likely going to support trace origination. What I don't want is when this agent's called and this agent doesn't respect an actual trace ID it gets, that it's originating its own trace, and then I lose that end-to-end path, right? So I need to make sure that I can wrap and instrument every agent regardless of the framework that it was implemented in. Even if it's not local, I want to be able, if it's invoked via A2A or agent-to-agent protocol, I want to be able to make sure that I can not only originate at the point of user input that trace, but then that trace can be propagated, whether the agent was implemented with trace propagation or not. So that's origination. Propagation not only has to happen for each agent, but we actually want to make sure that's passing to the LLM and to any tool servers we call. Tool servers are another key source in these architectures of where traces might be dropped if the tool server implementation was not instrumented in the first place to propagate tracing. Again, we can take a strategy like wrapping that tool server to actually make sure that every time I get a request to a tool server, I'm actually propagating a trace ID and making sure that's part of a span. And then finally, context. So here we're not just talking, certainly the request and the response are very important, whether it's an agent talking to an LLM, so I have a prompt and then a response coming back from the LLM. If with a tool server, I have a request going to the tool server and then I have a request back. For an agent, I'm calling, I'm invoking a skill, like that's a task for the agent. These request responses are still important. But in each step of this journey, in each span, I need to enrich with context-specific information. For the LLM, I want token counts and provider and model details. For the tool server, I want to know which specific tool was called and the tooling metadata around that call. For agents, I want to know the specific agent provider, the version of that agent, everything that I'm going to need when I'm explaining the behavior of this scenario end to end to basically give me that information to explain what path I took and to improve it if needed. So when we think about this overall, we can clearly see now the differences about how OpenTelemetry and what we're doing for cloud native apps today serves as a great foundation, but there's key gaps that need to be addressed from a higher level framework, both at the networking layer and at the platform layer to bring this end-to-end observability to bear for agents. Definitely check out Agent Gateway and Kagent for a solution to that problem on how you can build your own agentic infrastructure with observability in mind.